So this is my project. It is a solar tracking solar panel. It uses, as you can see, 2 and 2, so 4 LDRs. It does that by using basically a voltage divider. So LDRs are light dependent resistors. The light is dependent to the resistance, so more light equals less resistance. Less light equals more resistance. It's more or less how this works. I made my own solar panel encapsulated. It's not the prettiest, but like I said, see if I can get this rotated back up so I can show you. But you can see right there, the red one, the red wire, that's voltage. The 2 yellow ones go back, and that's where the voltage is divided back going to the Raspberry Pi. They actually go to the MCP3008 chip, and then it runs into the Raspberry Pi. So it's actually not reading the resistance, but the voltage drop or difference. Originally, I used L293D chip, which is basically just a relay with a low. It's basically a relay chip. That didn't work, so I ended up using a 5-volt relay, 2 ways, and I wired it so it'll turn this motor both directions. That runs to the Raspberry Pi into the relay. It's actually ran on 2 batteries that have wired for high current. But yeah, I'll stop that real quick so I can show you some of the parts of it. And like I said, this is plugged in the TV. But as I'm rebooting this, the parts I used, the schematic, that's the L293D, which is this guy. Didn't work. It's also this chip. You can't really see it, but it's just an 8-pin chip. They look almost identical. I blew one up. That's when I found out. Well, actually, I found out after this chip, the one caught on fire and half of it melted, that these are only rated for about 0.25 amps, and I was drawing with this new motor I got, which is just from an old used drill. I was drawing about 3 to 5 amps, depending. So yeah, this is basically scrap. I didn't actually even use this. The schematic I ended up using was this one. That's how they're wired. So these are light dependent resistors now. Just a generic, just a 10K resistor with the voltage coming in and the ground at the bottom. These go in. This is the MCP3008 chip, and then this is the Raspberry Pi pins I use. I'll show you that in the schematic or in the PCB board because it's easier. Here's the relay. It just has 5 volts, ground, and then in the middle you can use whatever GPIO pin you want. I ended up using GPIO pin 8 just because I already have it programmed. Just wired in the motor to the way, so like if this relay's on, it makes the rotor rotate to the right. If this motor is on, it makes the motor rotate to the left. Pretty simple. For the PCB board, you can see right here, this is the MCP3008. So there'll be a resistor out here, but I have this all wired up together. So on my project, like you can see, there's the voltage in, these yellow ones. They go with a resistor, or the LDR up here, and they come down here, and on the inside they're wired to a resistor, then they come back to the Raspberry Pi for the voltage drop, and they're grounded there as well. But yeah, and then on this side it's just the first 2 go to the 3 volt on the Pi. This is the ground, SCLK pin, MISO pin, MOSI pin, CEO pin, and the ground again. It's a pretty basic circuit. Originally it started out pretty complex. That's why it's a bit of a mess. I'll open it up for you. I actually have 2 different boards. You can see one back here, because I originally used, instead of a relay, that's the where it's all connected, and this right here is the MCP3 chip. I could have all done that on one board, but I originally started with an L293D chip, which means there was a lot more wiring. Turns out I couldn't even use it, so that was just a waste of time. but that is my project. I can show you the program real quick. I actually had a bunch of over here. These are all tests I tried, and they all failed for some reason or another. Most of them I tried different GPIO pin controls. But up here is just a SPI-DEV, which is calling so I can use the MCP3008 chip. And then I go down, it's calling GPIO ports, importing sleep, and more GPIO. This one is actually just a repeat. I could have deleted this one. I just didn't notice it till right now. Doesn't make a difference. You're just importing it twice. Doesn't affect it all. This is allowing it so you can use MCP3008. This is setting up my channels, so I can have 8 channels if I want. That's not really a need. See if I can get it a little better focused. Yeah, there we go. But I want extras, so I only use 4, but I actually have on here. You can see in here, there's these wires. You could hook those up to another panel and hook up another relay and actually run 2 solar panels on this setup. Or you could, if you wanted more accuracy or something, I guess. But after 4 LDRs, it just kind of gets messy in here. I think you can see in a second. But then this is where it calls the 8 channels, so I'm pulling 8, and then this is initializing it. And then this is storing the channels into my data bits, which so it's A through G. This is enabling GPIO. Actually, technically, setting it so you can use GPIO, then turning off all of GPIO so you don't have any left on. And then here's my main bit of my program, which is just C and G, which is what this one is on the top, and then D and F on the bottom over here. But yeah, it's basically just saying if these two sum up, maybe, there we go. These two sum up to be added, and these two, it'll rotate, like I said earlier. Pretty simple program. It took me a lot of time to figure out best way to call GPIOs, best way to use SPI-DEV. I actually used another program. It was made by PySPN. There was 2 other ones I tried. They didn't work near as well, so I ended up settling with this one. And the GPIO controls for this were great, easy to troubleshoot, no problems whatsoever. So I stuck with that. But yeah, like you can see right here is battery, relay, MCP3008. That's just a junction board Pi. I have it plugged in. You can see HDMI. This is just a mouse, keyboard I have hooked up to it so I can show you stuff. But yep, that's my project. So there you go.